very good evening to all. Welcome to fourth season and first session of Water Thesis Club. Very good evening and warm welcome to all of another Friday Water Thesis Club. The idea of Friday Water is to bid the Fridays with fun-filled and yet fruitful activities for the future generation. Friday Waters has water talkies, book reading, thesis club, and water arts. The focus of Water Thesis Club is on bringing the student scholars who have done or doing a thesis alias research on water matters to the session in order to discuss with them the making of the thesis research and the issues around the subject covered. I am Ekta Gupta, the moderator for today's Thesis Club session. I am joined by Professor Sonia Gupta, Dean School of Architecture and Planning, Voxon University, as a discussion for today's Thesis Club session. For today's session, we welcome Dr. Shipra Singh to share her research on climate change and water source sustainability, Sun River Basin, India. Dr. Shipra Singh is an assistant professor at Miranda House, University of Delhi, India. She is an alumnus of same institute. She earned her master's degree from the esteemed Department of Geography at Delhi School of Economics, University of Delhi. Her PhD thesis and impact of climate change in the water source sustainability in Lower Sun River Basin exemplifies her dedication for addressing critical environment issues. She has incorporated soil and water assessment tools, SWAT, in her thesis as a modeling tool to explore the sustainability use of water resources. Dr. Singh has been a senior research fellow at UGC. She has also contributed as geospatial analyst with Sixth Grain Global Private Limited, wherein she calculated the crop calendar of various African and European countries. Additionally, she had privilege of interning with renowned IMD and NIH Roorkee. Her areas of expertise encompass remote sensing and GIS, hydrology, climatology, disaster management. Dr. Singh's passion for research is evident in her numerous presentations at both national and international conferences, where she has shared her groundbreaking findings. Furthermore, she has generously contributed to academia by serving as a resource person for GIS at various schools and Ramajas College University of Delhi. Her scholarly pursuits have also yielded multiple published papers in reputable journals. Beyond her academic accomplishments, Dr. Shipra Singh is an avid leader and a passionate educator. Her love for teaching complements her dedication to expanding the boundaries of knowledge in the field of geography. Welcome again, Dr. Shipra Singh. May I now invite Dr. Sonia to take the session further with her. Over to you, Sonia.
Thanks, Ekta, and warm welcome once more, Dr. Shipra. Again, I would like to just correct, I'm not a PhD holder, so please do not refer to me as doctor. But yes, thank you so much, Dr. Shipra, for having shared your presentation. It is not only very informative, but it is also deeply analytical. And what I loved about it is the way it is optimistic in showing a way forward. So we look forward to your presentation. As we have agreed, you have all of 25 minutes is all yours. Screen time is yours. Please make your presentation. And after that, we look forward to interacting with you. Okay? Screen all
Thank you, Sonia. Thank you, Professor Sonia. Thank you, Ms. Ekta and Mansi ji, for the invitation. I am just sharing my screen. Please let me know if it's visible. It's visible. Okay. So good afternoon, everybody, once again. The topic for my research is impact of climate change on water resource sustainability in Lower Son River Basin. So as we all know that climate around us is actually changing. Now, the impact of change can vary from place to place. It can be temporal, it can be spatial, as we have read in various reviews of literature, which has already been done. There has been enormous work on climate change. So, why climate change and water resource sustainability? This is what I actually I quite a lot of time I dedicated on this particular thing, that why climate change and how climate change and water resource sustainability are actually interlinked, because I was very definite on this particular thing that I have to work on lower Son River Basin. Now, there have been, as I talked about, there have been numerous literatures which have talked that yes, climate is changing around us, which has been put forward by United Nations Framework Convention for Climate Change, and very recently reiterated by like world leaders in Paris Climate Conference also. So when we talk about climate change, one of the direct impacts of climate change, apart from the precipitation and temperature pattern, it is noticeable on the water resources of an area. So when we talk about water resources, we have to talk about, or we have to see it through the lens of sustainability, because that is where we have to focus. Our plans and policies have to be regulated in terms of sustainability of each and every resource which is present in the area. So this is a diagrammatic representation of how my mind actually came to this particular conclusion, that how climate change and water resources have to be justified if I take this particular topic. So in my study area, this is very, very limited to my study area. There can be variations, and there are certain generalizations also which I have incorporated in this particular flowchart. So starting from, I'm starting from the back end, like I'm not starting from climate change, which is visible over here. I'm saying that, okay, in my study area, the dominant factor is land use, land cover change, which we will discuss in the coming slides. So there has been an enormous amount of land use, land cover change. By using the word enormous, I'm not saying that there has been a 20% or 30% increase or decrease in certain categories of land use, land cover. Since my area is a river basin, and river basins are very, very fragile ecosystems. So even if there is a slight change, it has the potential of drastically changing or altering the ecosystem, as well as the livelihood of people who are living in that particular area. So in my study area, which is lower Son River Basin, land use, land cover change was actually visible, which I calculated. So that has led to a change in, like, that has led to deforestation, land degradation, and desertification. So not necessarily always land use, land cover changes result in these things, but in my study area, these are the visible effects because of land use, land cover change. And it has happened naturally because there has been increase in population in my area. So urbanization, industrialization to certain extent, because my study area is still the primary economic activity is agriculture, like primary economic activities are focused over there. So that has led to the deforestation, degradation, and desertification has actually led to increase in surface runoff, soil erosion rates, evapotranspiration, and decrease in groundwater recharge rates. So all these actually lead to changes in water regime of the area. So when I'm saying changes in water regime, I am more so focusing on the surface runoff. I'm not talking about groundwater rates, because I have incorporated a tool, a modeling tool, to study this climate change and water resources, impact of climate change on water resources, which I'll discuss in my coming slides. So when these changes in water regimes have been seen in that particular area, it gets further aggravated by the changing climate, and that leads to change in land use, land cover change. So this is a cyclic cumulative causation theory, that if there is a change in one part of the cycle, it will lead to changes in all other parts of the cycle. So this is a systematic kind of change. These are some previous studies which I was discussing, like apart from all the reputed bodies, there are various, for example, when we talk about IPCC, or when we talk about National Action Plan on Climate Change, which has been like a very important report in Indian circle, which was published in 2007. Then there is World Water Development Report. And there are various notable authors who have talked about that climate change leads to the alteration of the hydrological cycle. So I had a base that, okay, this happens, and then I kind of built upon that prerogative. So this is something about my study area. So as we all know, Son River, it is a southern tributary of Ganga River Basin. So this actually passes through four important states of India, like Uttar Pradesh, Madhya Pradesh. It originates in Amarkantak Hills of Madhya Pradesh, and then it passes through Uttar Pradesh. Then there is some parts of Jharkhand also, and then the mouth is near Patna. It meets the Ganga River. So this study area, my study area, becomes all the more very, very important because population density is above 400 square kilometer in this area, and this is an agricultural watershed. As I talked about, the primary economic activity is the dominant activity in that area. So and also Son is notorious. It's known for changing its course. Like in the last 100 years, it has changed its course quite some time, and a river changing its course is something very, very serious, and it has happened because of the increase in sedimentation, as well as this urbanization and industrialization, as well as deforestation have played there an important role over there. So why I have classified LULC, because as I talked about, for soil and water assessment tool, LULC has to be classified for whichever year you want to see that whether there is a change in the water regime of that particular area, or how that river is actually behaving. So I have used this freely available data from Earth Explorer, United States Geological Survey. And since the resolution is 30 meter, we have a limitation of actually having how many classes we can have. So I have classified like agricultural land, barren land, sediment, settlement, vegetation, and water body, which are the dominant classes of land use land cover in my study area. I have, through this particular map, as you all can see that there has a change in various classes which have been taken up, but two important results which is noticeable over here is that in 1991 agricultural land was somewhat 37% of the total area, which increased to 43.65% in 2020. Similarly, vegetation was somewhat nearly 56% in the study area, which decreased to 49.33% in the area. Apart from it, barren land has decreased, as is seen everywhere in the global area, that it is utilized either for cultivation with the use of fertilizers and with the help of pesticides. It is either converted into agricultural land, or it is used for commercial activities, or probably for settlement. That land gets converted into. Over here, settlement has increased from 0.43% to 3.03% in the last around 30 years, whatever changes we have seen over here. Water body, this is something conflicting, like 2.56% it was in 1991, which increased to 2.81%. It will make sense in the coming slides. I'll show how it has increased. This is the map which just depicts whatever is tabulated over here. Now, when we, okay, I'm not able to move my slide. I think it's there. Yeah, okay. So this is just whatever I discussed. It's written over here that the area has seen obviously an increase in population as it's happening all over the world. And that is why there has been an increase in agricultural land. Major crops cultivated are rice, wheat, sorghum, and lentil in my study area. And this is this area is actually known as rice belt of Bihar. Also, Son River passes through certain parts of Bihar, but that area is actually known as rice belt of Bihar. And in everywhere, like in all the 4 states, these are the 4 dominant crops which are found over there. This is so when we say in researchers language that you can't classify land use land cover and not talk about land use land cover matrix, because how do you know that which area? I just simply put that, okay, 7% increase in agricultural land has been seen from 1991 to 2021, but it is also very, very important to know that which land got converted into, from where that 7% land actually got transformed into agricultural land, or where that vegetation land went. Like when we say that, okay, there has been a decrease in vegetation land, so wo 7% kidhar ko gaya? So that will be actually justified by this land use land cover matrix table. So now when we see these diagonal values, I'm pretty sure everybody, like most of the audience, would be knowing about it, but just I'll take 1 minute and explain that this diagonal value is the unchanged value. Like when we talk about, so this is 1991's value, this is 2020's value. So over here, when we say that vegetation, so 2,711 hectares of vegetation got converted into barren land. Likewise, this much amount of vegetation got converted into agricultural land. So this is how this land use land cover matrix table makes us understand in a more detailed manner that, okay, land use land cover changes are happening in the study area, and this is where things are getting converted from one class to another. Now, when I say that there is an increase in water body, that in itself is a very, very a debatable kind of thing, that how water got increased in your study area. So because in my study area, there are important dams in my study area. There is Indrapuri Barrage is also there. So there is a Indrapuri Barrage. There is Bansagar Dam. So this study area, like if you see in 1991, this is an index, normalized difference water index, which is calculated with the use of geospatial tools. So over here, if you see in 1991, this blue thing is the water body and the pink is non-water body. So you would be seeing that blue, there are traces of blue everywhere. So these are just water bodies. Now, when you talk about 2020, over here, there is some bluish water body which has just come out of nowhere, but it is not like that. This has been because of commissioning of Bansagar Dam. It got commissioned in early 2000. So that is why in 2020, there is an increase in water body which is being shown in the water area. Now, this is something which is the main topic of our presentation, that how do we assess climatic scenario and its impact on water resources. So I have used a model, soil and water assessment tool. This is the result. Actually, the screenshot which I'm using in the background, it is actually how, when you will be successfully done with your soil and water assessment tool, result will be something like this, visible in the form of a graph, where it will be telling everything about the system, that, okay, see, in this particular surface area, this much was the precipitation, evaporation and transpiration rate was this, potential evapotranspiration rates are something like this, then your recharge to shallow aquifers, deep aquifers, everything will be mentioned by the model itself, if all the steps are followed correctly. So I've just used the background. I'll talk about it in my coming slides. So when we talk about soil and water assessment tool, this has been a verified model. It has been actually invented by United States Department of Agriculture's. There's a branch of it, Agricultural Research Service. And it was basically invented just to understand the simulation of hydrological cycle and water quality in agricultural watersheds. So this model is best used in agricultural watersheds. There are recent studies also where they have tried to use it in glaciated areas. They've also used it in forested areas, but results are exactly like ditto. You can say that whatever, as we say, model is what? Model is just a hypothetical representation of reality. So when you say that, when you go to that study area and you see something happening, it is exactly replicated by the model if we do the input things very, very correctly and follow the steps. So what I've done, since I have calculated land use land cover from 1991 to 2020. So I've seen that how the system behaved in 1991 and how it is behaving, or how it behaved in 2020. And using the same model, I've also done a hydrology prediction, that how the same system with all the same components, it will behave in 2045. So in simple layman's term, what will be the quantity and quality of water in my study area as compared to it was in 1991 and 2020. So this is the methodology which is used for running this particular model. So for this model to run, there are 5 very, very important parameters which we require. First is your land use land cover map that has to be done. Then you have to take a soil map, then your digital elevation model, how that just to calculate the stream network and then to delineate the watershed, whatever area you are working on. And when we talk about climate change, one important question can come in our audience mind that we are talking about this model, we are talking about climatic, you're talking about climatic resources and water availability, but where the climatic parameters are being used, how come to justify it? It can be justified because this model is a holistic kind of model where it is taking all parts of the system. So when we talk about climate, it actually uses rainfall data, temperature data, relative humidity, wind speed, and solar radiation. Without, if any of the components are not there, this model will not run. So these 5 parameters have to be there. After that, your LULC map, I've just like we calculate, then we take the soil map. So these are the maps which are required. Now, when we are saying about LULC, this digital elevation model, you can classify the categories as per your study area. Now, since my study area was a bit of plateau area also, then there was like the gradient was not much very steep. So I've just classified it into 3 areas and it has served the purpose. LULC classes are like all the 5, but SWAT has an inbuilt kind of system. So it's not like that you classify LULC in your ArcGIS or something like that and you come over here and you do the same classification. It doesn't work like that. But when you are saying that LULC classification, SWAT will reclassify it. It will not work as if I give an output map and then it has to take it as an input map. It will not do like that. So this is there. Then soil classification also has to follow, since it was invented by USDA. They have their own like legend pattern. They have their own taxonomy. So we have to actually declassify based on our Indian in weather stations. So I have taken data from all the 17 weather stations and then an average has been calculated. This is the rainfall and temperature graph. So this is the input data. SWAT. If any one of it is missing, the model will give incorrect results. So now I have also divided my basins into 9 sub-basins. I'll tell why. Because merely just studying the problem is not going to give us any kind of a loop in the future. We have to also study that which part of the system is actually getting affected or it is the worst affected, so that the plans and policies can actually focus on that particular area and the health of the watershed can be improved. So this is why it has been classified into 9 sub-basins, and it is in line with what our CWC, like Central Water Commission, has classified. All of you can go and look up the WARIS portal, which is by CWC and IMD. So over there also these sub-basins have been actually reclassified. Now, for this particular model calibration and validation, yes, apart from all the input data, you also require discharge data. So that I got from Coilworth station. So in my study area, there are 2 GDSQ stations. So I got the discharge data from there. And then I calibrated and validated my model using the discharge data. So after giving all the input data, SWAT will give you a result that, okay, your study area is behaving like this. If I give that these are the crops, so it will take the irrigation pattern of the crop also, and then it will give that water yield of the area is something like this. But how would I know that the result which has been given by the model is true? So then I have to calibrate and validate it with the help of discharge data, which I have acquired from the station which is present in my study area. So when I did that, I saw that the model is giving exact results like the observed. This is if you see the blue and orangish pattern in the graph, this is the observed and calibrated patterns which the model has given me the results. And this is the green and blue, this is the validated part. So this proves that my model is working perfectly fine, as there are certain, these are technical stuff like what is the Nash Sutcliffe in my study area, what is the correlation factor, and what is the p-bias. So all of that was within the permissible limits. So I can say what I am writing in my findings. And also one important thing is that the hydrologic cycle of SWAT model, it is based on the water balance equation. So how much water is coming into the system, how much is getting utilized, and how much is remaining. So everything, this is a very mathematical kind of a model, as all the models are, but it is also incorporating the human needs and behaviors, like what kind of crop is getting calculated, how much water that crop will require, how much water that crop will require if there is additional pesticide or if there is manuring done in that study area. So this Liberty SWAT gives us to incorporate, and then it will give the water yield. So now this is what I had used, the first picture, when I talked about assessing climatic scenario on water resources. So when we say that which is the sub basin or how it is actually behaving, it will tell us that, listen, this particular part of the basin is severely degraded, maybe probably because of the soil erosion rates, maybe because the surface runoff is happening more in that particular area because of the deforestation rate, or any of the factors which are present in that particular study area. So apart from it, it will also give us that how the crops will behave, how much fertilizer. So NP is actually, so nitrogen and phosphorus is calibrated and validated by the model. So how much mineral nitrogen is required by the crop, how much mineral potassium is required. So this will also make us look that how the cropping pattern is actually getting shifted in the study area, or how the farmers are behaving over a particular period of time. So if in 1991 there was 1 gram of nitrogen or potassium getting used for 1 hectare of land, in 2020 is the pattern same or has it changed? So this model is holistic in this manner that it will study all the prerequisites which are required in an agricultural watershed. So the findings after applying this particular model, these are the 4 dominant findings which are visible to us. When we talk about the blue line over here, will depict the system, how it was behaving in 1991, and this is of 2021, or the orangish line. So coming back to this first stream flow, we now say that stream flow has increased. Like initially in 1991, like it used to start during June, and then the stream flow it would peak and then it would decline coming to the month of, as we approach towards December. But here there has been an interesting trend that stream flow has started increasing from April only. Likewise, water yield in the study area has also increased. The months have actually increased in the study area, which is not a very like a thing to worry about, because increasing water yield, as most of the people, they say that okay, there would be more water to utilize for domestic as well as agricultural purposes, so that is fine. But what is very disturbing over here is this surface runoff and evapotranspiration rates. So this gives us a very clear picture that surface runoff has decreased, and it has decreased considerably. The time period has increased, and this time period is not actually in sync with the crop calendar. This is what is disturbing. So now the farmers have actually started planting, or they have started showing their crops much before. Like the kharif crops are being, the crop calendar has actually shifted. Yeah. Now, and also the evapotranspiration rates, because of the climatic change, the increase in temperature, because of the deforestation, because of the increase in the built up area. Also, these things are getting increased. Apart from it, now the important aspect of this study was to predict that if the same land cover would be constant, which is not a realistic thing. But since if I want to say that LULC is constant for supposedly in 2045, the LULC will somewhat behave like 2021, then keeping everything alike, how will the water system behave, or how will that Soon River Basin behave in 2045? And the picture is alarming. Average curve number has decreased. It means that there will be more increase in surface runoff. There will be an increasing surface runoff is not only a singular problem, it will lead to cyclic changes. It means that there will be decrease in your groundwater recharge rates also. There will be decreasing return flow, increasing precipitation. It will also lead into increase in evaporation and transpiration rates. There is less percolation to shallow aquifer as well as to deep aquifer. So clearly the groundwater recharge rates are diminishing in that area, and it is visible in the primary survey. People used to say that earlier we used to found like we used to dig a well or probably a tube well, and we would be finding water at this particular height, but now things are changing drastically in the study area. So this has been actually proven in the primary findings also, that this is how the system is behaving in that particular study area. So now, as it has been reiterated earlier, that prediction for water availability in the basin, it shows increasing precipitation with increasing surface runoff, and the figures are alarming. It's not something quite close to, like in 2021 it's 293.36, but it has increased to 343.45, which is like this precipitation is increasing. So clearly it is, the system is showing signs of climate change in the study area. And then it is also decreasing return flow. So return flow, as we all know, it is used for various purposes. The water is actually recycled and it is used for various, even if it is not recycled, the same water is used for various purposes. For example, for domestic, for commercial purposes, and then it flows into the river back. So that is also decreasing. So these changes are leading to unfavorable conditions for the future generations. It is not only problematic for future generations in terms of water availability and yield, it's also it will affect the people's livelihood of that particular area, because people's primary agriculture is the main economic activity in that area. And if you don't find water to use, or if the pattern is actually shifting, their livelihood is actually synced with this climatic calendar. And if this is shifting, their livelihood is going to be affected by it. I hope I have 5 more minutes. I just want to focus on this. Okay. So as we talked about this, identifying and prioritizing critical sub-basin is also important. We saw what is the problem in that particular study area, but it can't happen that the whole study area will behave similarly. There has to be certain districts or certain places which are either doing something not to worry about, and something which is very, very worrisome. So what I did was that when SWAT gives you various kinds of outputs, so using this analytic hierarchy process, this is a problem solving framework where it has been given by Thomas Sati, and it was also devised in 1990s. So he has given a kind of scale that, okay, listen, if 1, so this is equal importance. If there is 3, so somewhat more important. So you do comparative analysis of various factors, and you come to a conclusion using a mathematical kind of analysis. So I had the parameters, like how have I done this? That sedimentation of the whole sub-basin was given, the SWOT model. It had actually classified our study area into 9 models. Like I had given that command, and I classified into 9 sub-basins. So for all the sub-basins, I have that this particular result. Like I know the sedimentation rate of each and every sub-basin, soil water content, surface runoff, nitrate concentration, evapotranspiration, and stream flow. So this is how singularly these factors were actually behaving in all the sub-basins. Now, what I did was, using AHP, I compared all the 9 sub-basins on the basis of these parameters, and I calculated consistency index. And after consistency index was calculated, the final map was, using overlay technique and using the raster calculator, the final map was prepared. And this actually, then it was reclassified, that which areas are working fine. Working fine means that there is low sedimentation rate. Soil water content is perfectly fine over that area. Nitrate concentration is also up to the government permissible limits. So all those things which were behaving fine, it was when after preparing the map, it was overlaid. We saw that this number one, if you are able to see, number one and number two, these two sub basins were at the very high risk zonation. So if in these two sub basins, even if sedimentation is controlled, so how sedimentation will be controlled? Like if deforestation rates are actually controlled in this area, afforestation or reforestation measures are being taken, if people are not like allowed, obviously there is in this particular study area, illegal sand mining is a base is a concern, and this is how you see high sedimentation rates. So if these two sub basins are checked, then the health of whole lower Son River basin will be, I'll not say that it will improve drastically, but yes, it will be controlled to certain extent, and it will start working, like we will be working in a positive kind of direction. So out of the 9 sub basins, if we are able to manage even 4 or 5, problem will be actually solved to much like higher levels, and then we can talk about Son River basin behaving as normal. Now these are certain news clippings I've taken from these national newspapers. And apart from government has like various rules and policies on paper, and they are trying their best also. But illegal sand mafia, like we have a very sand mining activity going on this particular area, because it is believed that if you use the river of sand, like the sand of Son River basin, your house, like there is something special about this particular river, and people use this sediment or sand for their houses. But there is another factor. Like when I went into the field and talked with common people, they were also okay with the illegal sand mining, only because of the money which they get. Like they were like, if we are getting 300 rupees after working in the day, in the night if we go and if we dig this much of, or if we put or overload a truck or something like this, we are getting 300. So that is an additional employment for them. So they are not aware about the environmental causes and concerns which this is actually creating. They are okay with it, and this is how the illegal sand mafia is working over there. So this is a big nexus in my study area. Now, these are certain glimpses from the field. As I talked about, this is paddy cultivation, which is going on. So this is, as we said, the rice belt of Bihar. So rice cultivation is the dominant one. Now, if you talk about the first one, you will be seeing heaps of sand lying and trucks, because it is going on. If police tries to stop it or something like that, they will attack the police also. And there is obviously, there are certain administrative lapses and lacks, which the government is working on. Hopefully in the near future it will be fine. Now in the second picture, if you see, this is Indrapuri Barrage. Now, because of the sedimentation, out of the 17 gates, 9 gates are not working. And if it is, I don't know how much visible it is in the presentation, but it seems very, very golden in color. The water has changed golden in color. It is only because of the sand which has gotten deposited in the barrage, and 9 gates are actually shut in the study area. Then there is another, this brick kilns are very, very common in that particular area. So after every, say, 50 kilometers or 100 kilometers, you will be finding a brick kiln in that area. Alkalinity of the soil is a problem because of the sedimentation and the decrease in water in that particular study area. And since people are dependent on primary economic activity, they are using fertilizers to increase the crop yield in that area, which is affecting the soil quality of the area. So what are the strategies? How can we control them? So the most important one is curbing illegal sand mining. Then we can take afforestation, because that will stop, or to certain limit it will control the soil erosion rates in the study area. Crop diversification is still one of the important factors which have to be introduced in that particular area. People have actually started crop diversification, and crop rotation is a common thing in the study area, but crop diversification needs to be done on a larger scale in the study area. Then checking over irrigation and stopping excessive use of fertilizers, because soil quality is getting compromised to a larger extent. So this is why this study becomes important, is that river basins are geophysical units, and changes are observed in Son River Basin, and those changes are actually, it has started affecting the environment to a certain extent in the study area. And if it is not controlled, it can bring on a large, or it can have devastating impacts on the environment, because as I told in the beginning, Son River is notorious for changing its course. And if sedimentation is not controlled, there is decrease in the water quality is also compromised, and there are chances of Son River changing its course, which will lead to flooding as well as drought in times of your monsoon, and that will lead to the impact of people getting their livelihood impacted. So I hope I didn't take much time. Sorry, and thank you.
No, Dr. Shipra, I think your presentation was very clear, very comprehensible, and believe it or not, very enjoyable as well. So
Oh,
yes,
thank you.
kudos to you. Quickly coming into the interaction part. Firstly, I was just wondering, going through your presentation, you have said that, in definition of climate change, you said that uh, it's a way, I mean, about humans and ecosystems must be able to sustain life for in future. Is there any way to assess the needs of future? Because we are prospecting. We are not. Is there any tool to assess really the needs of humans?
I think this is a very, very subjective kind of question. And as I think everybody has this statement that there is enough for everybody's need, for not for greed. So needs actually change. And I will not say that it only changes because of greed, but as talking about my study area, so people are trying to shift from primary economic activity to different kinds of livelihood, because now they are seeing a stark change in the, as water was freely available for irrigation, they were able to actually feed off from that particular resource which was there in the study area, or in lower Son River Basin. But now, since there has been an increase in population also that area does not have much like commercial activities. So I think that needs change also because of compulsion, and also because they have to earn, they have to make a future, or they have to make a living. Most of the people live from hand to mouth in that particular area. So it's just a forced kind of need. But yes, assessing needs, it is I think when governments, like they publish their reports or something like that, what they do, or what as researchers we can do, is that when we do primary research, obviously we get certain kind of idea like what is happening in the ground. So probably based on the resources, natural resources in the study area, and how they are getting utilized, that is only one way, but it is very, very subjective. I would say I have not come across a model which would assess the needs of people who are living in that particular study area.
Absolutely pertinent. So I'm just wondering, you have already brought on the topic of the lower basin of River Son, and that's your study area. But you just, in your last answer also, you said that, that is an area where people are not, they are living hand to mouth. It's not like there is a very rich population over there. Wealthy, not rich is not the right word. But I'm just thinking, so is that one of the reasons why you chose that place? Because climate change is affecting the whole world. So is that one of the reasons why you chose, or is there a reason why you chose that particular area to exemplify your study? Yeah.
Yeah. Okay. Thank you for the question. First, I would say that yes, since this is very like PhD based kind of and very close to my heart, I was very sure that okay, I need to incorporate this soil and water assessment tool in my model, because I knew in the study area, since I belong from that area only, like my native roots are there, and I've seen how that place has changed over a period of time. But merely saying something in research will not make a point, or nobody will listen to you if you say that okay, this is what is happening. So you have to prove through your finding that no, this is happening. So since I had seen that area, I have been from that area, illegal sand mining has been a concern. When I used to go back home, I used to see all these heaps of sand lying over there, and then I used to ask my father, since like my uncle, he is in the administrative services, that why is it happening actually. So he's like, the problem is not only this, the problem is really big, but nobody is talking about it. People are forced to actually do these kind of activities because their primary activity is getting compromised in the study area. And also when you use soil and water assessment tool, so it has a limitation also. Like I wanted to use the whole Son River Basin. I wanted to do the water availability and quantity analysis of the whole Son River Basin, but the area was very, very huge. And in SWAT, if you want to do, I would not say that large areas are not validated, but actually when you are using a free software of that particular model, your validation, the reiteration will not be that. So because of technical limitations also, I use that thing. And also IITs have done work on whole Son River Basin, like upper and lower Son River Basin. So they have published really good reports. Like if you see this IIT Roorkee, they have done an excellent work on Son River Basin. So that is why lower Son River Basin was something very, very neglected. And since I had this emotional kind of attachment and I knew that changes are happening in that study area, I chose this.
Wonderful. Yes. So also I'm wondering that in the sense that, you have statistical documentation of how the average stream flow has increased, right? And you've given
Right.
us a set of flat reasons why you think that has happened, or not you think, you have actually also fortified that with statistical data. But why I'm wondering is that there is in certain months, right? You see that
Right.
there's yeah. So do you think that there is a reason for that? I mean, if you
Yeah.
could come forward and then say, so therefore, since it's happening in certain months, can we offer a temporal solution?
Yeah. So temporal solution, I'll come back to the first question of yours,
Yes,
that
yes.
why average stream flow. So it is only because of the changes in the precipitation pattern. So when changes in precipitation now in that particular study area or on the whole of India, even if we see that monsoon was always very, very erratic in our country, but now it has become more so very, very unpredictable, if we say. So in my study area, it has started raining from the month of April, more so in those like the time period which I have studied, like 1991 to 2020. I'm talking about that particular time period. So monsoon has come earlier. So when precipitation rates are increasing, just for that, average stream flow has increased also because of the deforestation happening, which has happened to a larger extent in my study area, an increase in built up area. The average stream flow, you see the stark difference between 1991 to 2021, where the graph has flattened actually. So it has started from 1991. So now the temporal solution, what I could think of certain things, if I can reflect upon, is that obviously afforestation or just not to cut more trees. The deforestation has to be stopped. It has not stopped in the study area. Practically, when we are talking about it, some trees are being fallen over there. So deforestation has to be stopped, and also illegal mining activity. If you see some days before only, I think a week before, Sonbhadra actually of Uttar Pradesh, it lies in this particular Son River Basin only. So over there, the government has actually passed an order on urgent scale that illegal sand mining has to be stopped at all costs. And then the companies who have done that, like obviously if it's illegal, there is no registered company as of such. But this is what I read in the newspaper that the companies who are responsible for doing sand mining, they have to have an environmental cost. So I failed to understand that how come illegal sand mining companies are actually registered or things like that. So that has to be actually stopped on an urgent scale. Then, and also in the areas where when we see the critical sub-basin, the sub-basins which are more so impacted by that have to be treated on an urgent scale. That is the temporal solution which I can think of based on my study.
Right. Thanks. I'm just also wondering about percolation, because that's one of the things we talk about, that, we take out water at an unusual rate, from whether it's from shallow or deep aquifers, and then we don't recharge them. We don't make arrangements to recharge them. So would you suggest any ways that percolate, like we're talking about afforestation? I know for absolutely for sure that afforestation is one of the ways in which you can increase percolation. But when we talk about human needs, which you also mentioned, human needs, right? So we have to have agriculture, we have to have buildings. So how do we balance this afforestation and agriculture, and then human needs for other requirements as well? Any kind of pointers towards that balance?
Yeah, very, very tricky one to answer actually, because we have to have like development has to happen for the economy to sustain. And obviously, there's one thing that you can't die out of hunger and poverty and talk about conservation of nature. Yeah, so this is very, very something, a very debatable kind of thing. But yes, countries are doing. Some of the countries are, when you talk about river basin management, some of the countries have done it excellently. So how come, if we talk about like development patterns, if we talk about the exhaustion of resources. So I think probably the concretization of surface which is being done, because when I predicted the hydrology of 2045, drastically and very, very surprisingly, the recharge rates to both shallow and deep aquifers have been are getting affected. So from where the groundwater will be coming? So either over there, like in Delhi, we have a policy over there. The government does not have, like, it has not banned extraction of groundwater. So they still have those chapakals and they still use those tube wells in that particular area, because piped water supply is still a concern in some parts. I'm not talking about all the parts of Lower Son River Basin, but in some parts, it is still happening. And also, people are not aware, as I talked about, like they don't see any wrong in illegal sand mining because they are getting some money out of that particular activity. So I think just to for this recharge rate, people have to be sensitized. Everything will start when people are sensitized, and obviously government has to have some groundbreaking rules, and they have to see that they are implemented. Not only rules, the rules have to be implemented. So probably that will solve some part of this problem.
Right, proper enforcement. There are,
Right.
I'm sure there are rules, but there is, of course, a lot of loopholes in the enforcement part. I get you totally. Mansi, would you like to jump in and ask your question?
Oh, I get my chance. Thank you so much, Sonia, for allowing me every time to ask some questions. And thanks, Shipra, for the wonderful presentation and the detailed one, I must say, to really enlighten us on what's going on in the basin of Son River. I did realize when you were presenting these layers of showing the in the course manner, you had this map, this 8 maps where you were showing all the courses and telling which are more alarming areas. So in a way, you were grading the whole land and talking about where more attention is required, or more, where you can really do something or save things here. And I want to bring that point back to the three tenets of climate change, which you talked about, DLDD. I think this year United Nations has also made it their flagship program to talk about this World Environment Day was dedicated to DLDD. So deforestation, land degradation, and desertification for that matter. So I would like to understand from you and also suggest you to, if you can take those maps further and maybe come up with some maps to tell us that these are the lands. So basically, I'm talking about really adding a land use in, it can maybe a hypothetical, or it may be a policy recommendation to talk about even the cropping pattern. What kind of cropping pattern may really help uh, save water, or what may help reduce the return flow. I mean, sorry, increase the return flow, because you already mentioned there's an increase in the surface flow, but there is a decrease in the return flow, which are all, of course, they are directly they are related. So, do you think that your model, because you also had a very good example, because you really used an established model, so you don't have to really be bothered about when you talk about using surface model. Do you think it allows you to take it further to come up with these kind of recommendations? What I am keen and why I am asking this question: can we revert or reverse, let's say, the degraded land back to afforestation? And I'm not a very much advocate of permaculture per se, but permaculture is in a way in between agriculture and forest. So, simply put, will those maps be useful to take it further to give policy recommendations for afforestation in selected areas of your study area? Simply
Thank
put, a
you.
lot of
Yeah.
introduction in the background. I had to do it. It's a kind
No,
of
glad that you
summarization
asked the
in my mind.
question. Yeah,
Go ahead.
glad that you asked the question.
I read
Because see,
all my presenters' work, so I'm always prepared. So,
no, great, wonderful to hear that question. And as a researcher, Mansi, I think you would also be, or all of us over here would be really, like, when we work on a topic, we're really enthusiastic that, okay, let's have, after the results are out, how can we make a change? So
make
obviously we
use.
can't go knock
Yes, of
on
course.
door to door and say, so we
Yes,
really want, we have this honest request from our side to the government that, okay, this is the result which
yes,
I have taken out from my
yes.
study, and probably this is our inherent kind of like curiosity that something would happen on that particular research. And I did
Mm,
that. Like, I have submitted my
mm,
research findings to Coilbur GDSQ station. So now when I talk about those maps, yes, there are chances. In fact, I'm talking, like, I'm working on that particular thing for bringing a paper on it.
mm,
The thing over here is that I would not say, like, practically speaking, I would not say from my research findings also that all sub basins, even if you do more than 100%, if you bring 100 more than 100% also to the table, it would not be reversed, because environmental systems are
mm.
such that once they are
Absolutely.
altered, something or the other, there will be some kind of retrofitting it would have. If you have
Absolutely.
a cut on the
Restoration
stream,
itself is
yeah, obviously
changed
it
landscape.
you want to have, like, plastic surgery will also, like, leave a mark or something like that. So that is something
Absolutely.
which I don't think that we can go back to that particular feeling. But yes, obviously, why using a sub basin if it is not helping? It will help. It can solve, say, 50%, practically speaking, 50% of the problem, because we have to keep into mind that population is increasing, and when the population is
Mm,
there, you have to understand that what is the awareness level of the people living in that particular area. Are they really willing to make all those little changes? Because in that study, in my study area, I saw a lady. I'll just share a snippet in from my field visit. I saw a lady, and she had a bucket, and there's a tap. So you have tanker water going on in that particular area, and the
mm.
bucket was actually overflowing, and she was sitting and having her hookah. And I was like, oh, it's overflowing. So doesn't matter. They'll bring another tanker. You have
Oh,
tankers
that's
every
very
6
common
months over
scene.
there.
Oh, that's very
So
common scene. You go to villages and you see they are actually drawing groundwater and filling the ponds. It's a
right.
very common scene
Right,
across
right.
India.
So when I talk about all those maps, yes, those maps will tell us that in which direction. In sub-basin 8, if I'm saying that, okay, all
Yes,
the factors are actually very, very dominant over there. Like, sedimentation rate is drastic over there. So you have to
yes,
work on sedimentation, and probably if you can check, or if you can arrest soil water or soil erosion in that particular area, probably 30% of the problem will be solved. So that sub-basin, the demarcation will tell me that whether that sub-basin is lacking in soil water content or
Yeah, so
there
what
is
should
more
be
use
done
natural.
where? Yeah,
So
absolutely.
yeah, so what
Absolutely.
should be done over there? And if there is like if we have this timeline, and then we are saying that okay, within this particular year we have to control this much temperature and precipitation, and then we have to also take care of the population living in that particular area, those maps will actually serve as a base that this has to be done in this particular sub basin, and probably you can meet that timeline if everything is done in a very phased manner, and if people are also supportive of your endeavors, like policies have to be
Absolutely.
implemented really in a phased manner, and people have to those behavioral changes have to be brought in the
Yes,
population. So I think
absolutely.
yes, those maps will help us in future studies, right?
I'm not a big fan of afforestation. I will be very honest on that. I have never been a big fan of plantation either. I know a lot of people boast on plantation, and when I see when these plantations are happening with drawing groundwater, it gives me really, really scary feeling because we need to save more water than actually saving more trees. It's not a competition between trees and waters, but it really makes people understand. It really makes people not understand that water bodies are really crucial. Trees will grow if
Right.
there are water bodies. So when you showed that water body which is newly generated, and I'm also actually concerned about it that there is a new water body generated because it's going to bring more problems if in future if the way we are looking at precipitation and if the Indrapuri barrage is really taking that into consideration. But anyway, we'll talk about it some other time. I hand it over back to Sonia because there are some questions in the chat box, and there is a question which has come from YouTube. So maybe you can take both, and there's I think one person who is present here. So you may invite the person to pose the question. Thanks, Shipra. We'll talk
Thank
outside the
you.
session. Later
Yeah,
हम दोनों बात
surely.
करते रह जाएंगे, है ना?
Surely,
And I'm
Mansi.
proud of Anindita that I have to also mention that you are a proud student of Anindita
I
Sardar. So
know.
thanks,
Yes,
Anindita.
ma'am. Yes, yes.
She must be watching us from Germany. So she was here, but she is not here right
Yes, hi to Anandita ma'am then.
now. But,
Yeah, yes, ma'am.
Okay, so I think there's a question from Venkata Subbarao, and he's here. Could I ask you to please unmute and ask the question yourself quickly? No? Okay, question is, how does climate change impact global water resources, and what are the potential consequences for fresh water availability, agricultural productivity, and ecosystems? I think, well, answer it.
Yeah.
It's there. It's there.
Yeah,
Yeah,
I think if I'm not wrong, the question is that how climate change will affect water resources
correct.
and how all these activities will be affecting like fresh water resources. Probably this is I think I started my presentation with that when you talk about, see, not in all areas climate change will in water resources. We have to be clear with that thing also. So it is very, very situation dependent, and also what kind of area we are talking about. What is the topography or terrain of that particular study area? What kind of rocks are there? And not merely increase or not merely in like we are not talking about increase in temperature, but most of the people get confused with this, that climate change is only increase in temperature. So that is the climate is changing. No, it's not like that. Probably one of the direct impacts of climate change is increasing temperature or probably increasing precipitation, or it's the pattern that the changing patterns of that. So when you are talking about, I'll talk about my study. You talked about globally also. So globally, more or less the phenomena remains the same, that when climate is changing, obviously the evapotranspiration rates are also changing. There has been cases of deforestation, so your surface increase in surface runoff rates are high as compared to previous times, and that is leading to decrease in groundwater recharge rates. So there is no like practically if you talk about increase in surface runoff rate and you want to do a correlation analysis, that is as simple basic maths, that there is a decrease in groundwater, there is a decrease in return flow, So your hydrologic cycle is getting compromised because evapotranspiration rates, this is actually affecting your hydrologic cycle. And as is seen, like we have been sitting, like we were sitting in a gas chamber in Delhi just 5 days back, 53.6 degrees Celsius temperature, like 2 weeks back. So climate is changing. We have to wake up to that particular fact that no, climate is changing, and climate change will affect hydrologic cycle. That has been put by all the global organizations, which is evident in our day-to-day life also. And obviously, freshwater resources are limited. So how do you use, like you can't use ocean water for drinking purposes. Obviously, some people, like one of my students did counter question that, ma'am, you are talking about fresh water and ocean water not actually getting transformed into fresh water. You see what Israel has done. They have a technology, like they take ocean water and then they convert it into fresh water, and it is actually getting distributed to the public. But then we have to also understand the economic factor, the cost benefit analysis, that what is the cost of that particular water which you are using from getting like transformed into ocean water. And as a country, or can we sustain our population using that technology, or is it actually practically feasible? So it's not like that. We have limited resources. The best way is to focus on the sustainability of those resources. So that is how freshwater can be managed, and probably
Yeah, one more thing is, I mean, attacking the ocean, I feel so scared by the mere thought that we've also taken all that water. I mean, it's far too scary to think about. We don't do it. I think that's much better. And one more question, because this is from Chandra, and Chandra is a water expert, water treatment expert, actually. So he asks that details like over exploitation of bore water, and therefore arsenic, fluoride, uranium, which are, it's coming up. I mean, in water, those concentrations are much more than it should be. So this has not been addressed by you, perhaps in your studies, or he wants a comment on that.
Okay. So coming back to this, when we talk about contamination of water resources, so if we talk about arsenic contamination, that is more so visible in Bengal area, or probably if you come to Punjab, then you have this contamination of water. I'm not denying the fact that contamination of water is not or might not be happening in my study area. But since with every research, there is some kind of limitation. So I've only talked about the water quantity and quality. This is what I talked about, like impact of climate change on water resources. When we talk about water quantity and when we talk about water quality, so SWAT as a model will not talk about the contaminants which are present in that particular study area. And I have solely used SWAT as a model to determine the water resources of my study area. So probably in my next study, if I find something, obviously I'll work on this particular topic. But yes, this is the limitation of my study area, of my topic. And also the contamination, I'm not saying that it is a very prominent kind of problem in the lower Son River Basin. Still, luckily, water contamination is not happening much of that sort. But yes, obviously, next probably if I try to do a study, I will surely incorporate it. But this is the limitation. Right now, I've not worked on it.
All right. I think we have to draw to a close at the moment. Mansi, Ekta? Yeah? All right. Over to Ekta then.
Thank you, Sonia. Thank you, Dr. Shipra. It's really a very insightful session. And, sometimes unintentionally, we do a lot of damage to our environment. We exploit the things, as Dr. Mansi always say, and you are also shared, that the plantation is also not every time useful when it is contaminating or over exploiting the water resources. So everything has to be in a very conscious way, learning the facts and doing the things right way is the most important thing. So I think this is the major takeaway from this session for me, and a lot of knowledge sharing and the technical parts are there. So thanks a lot, Professor Sonia, for taking up this session, and beautiful questions by Dr. Mansi also, and our audience. And Dr. Shipra, it's really wonderful to host you here at the session. So looking forward for more research that can support, help the common people to learn how to conserve, how to take care of our water resources right way. So thanks a lot. It's time to announce for the next sessions. Next week, please join us for Wednesday for Water on June 26th at 5 p.m. to join for a discussion on from engineering to social ecological engineering. Next week, please join us for the next Friday Water Thesis session on July 5th at 5 p.m. IST on Sustainability of Jal Jeevan Mission, Insights from Ground with Prem Shankar Mishra. For joining these sessions, the details are shared in the chat box. So please go ahead and join this session, and also not forget to share the links with your connections so that more and more people can join or watch on YouTube channel, and if anybody can watch the recorded videos on our channel. So thanks a lot for joining everybody. Once again, thanks to Dr. Shipra for your wonderful presentation and your discussion and about your thesis. So thank you, Dr. Professor Sonia Gupta and Dr. Mansi Balbhargav. So
Thank you.
yeah, waiting
Thank you
for everybody for
everybody
the
for
next
having me.
upcoming session.
Thanks. Wonderful presentation and good
Thank
session.
you.
Thank you so much.
Thank you. Thank
Thanks a
you. Thank
lot.
you so much. Thank you. Bye bye. See you soon.
Bye.
Thank
See
you.
you.
Bye.
Bye. Thanks. Bye.